Okay, folks, this is question number 8 from an AQA exam past paper from the AS Pure Mathematics. Looking at some calculus here, okay, looking at some differentiation. You're asked to prove that the curve with the equation y equals 2x to the 5 plus 5x to the 4 plus 10x cubed minus 8 has only one stationary point stating its coordinates. Okay, so step 1, we're going to find dy by dx. Okay, so we're going to differentiate it. Okay, so the power comes down as a multiplier, and the power comes down by 1. So the power comes down as a multiplier, and the power reduces by 1. So we're going to have 10 to the power of 4. Okay, 2 times 5 makes 10, and then we knock 1 from the power. Okay, 5 times 5 times 4 makes 20, so that'll be 20x cubed. Okay, and then 10 times 3 makes 30, and then knock 1 for the power. So I'm going to put a 10 there, I apologize, my fault. Okay, 30x squared, and then minus 8 goes to 0. Okay, when you differentiate it, okay, give it as minus 8x to the power of 0. Okay, if you're unsure as to why that is, because obviously x0 here is equal to 1. So that's what, yeah, actually change the answer. Minus 8 times 0 is 0. Okay, we have 0x to the minus 1, okay, which just goes to 0. Okay, next, we're now going to set this equal to 0. We're going to solve. So we got 10x to the power of 4 plus 20x cubed plus 30x squared is equal to 0. Okay, so that's what, whenever we have a turning point, a stationary point, okay, in these words, okay, so yeah, so turning point, yeah, stationary point, okay, minimum point, max point, okay, so looking at derivatives. So yeah, here I'm going to pull out a factor, or multiple factors. So I can pull out a multiple factor here of 10x squared, okay, in brackets. So 10x squared times what makes 10x to the 4? Well, that'll be x squared, okay, so again, check with your laws of indices. X squared times x squared, okay, so base to a power times another base, to like another power, okay, so same base. We're going to add the powers. 2 plus 2 makes 4, okay, plus 2x. 10 times 2 makes 20. X squared times x to the power of 1, okay, or just x, gives us x cubed. Then finally, 10x squared times what makes 30x squared? Well, that'll be positive 3, or plus 3, because 10 times 3 is 30, okay, 10 times 3, 30, okay. And another thing you can see from here, this actually has no real solutions, okay, this quadratic, okay, because the discriminant here is less than 0. Again, if you check if you're unsure, so you have either 10x squared equals 0, or when the quadratic here equals 0. Okay. Again, I don't want to delve into too much wire, but hopefully you're happy that if you try and complete the square here or use the quadratic formula, okay, you will get the square root here of a negative number, which I can't actually solve. Okay. You can see by completing this square, hopefully at your level, okay, that I get x plus 1 all squared plus 2 equals 0. Okay, so minimum point here would obviously be minus 1, 2, okay, of that quadratic. Okay, it means it never actually touches it. Yeah, if anyone actually wondering, it looks something like that. Okay. So yeah, anyway, so 10x squared equals 0, divided by 10, so x squared equals 0. Therefore, x equals plus or minus root of 0, so x is equal to 0, okay? So this is like a repeated root, okay? So when x is 0, guys, what is the value of y? Well, I'm going to sub in x is 0 to my equation, okay, right from the start. So y is equal to, okay, 2 times 0 to the 3, yes, that'll be 0, 0, 0 minus 8, so that'll be minus 8. So the only turning point it has, or the only stationary point it has, is that the coordinates 0, minus 8. Okay, so remember, whenever you see the word stationary point or turning point or minimum point or maximum point, always think derivatives key, but in particular, if you see the word stationary or turning point, it means we are setting dy by dx equal to 0. Okay, so we're finding the first derivative and then setting that gradient function equal to 0 for the first derivative, and then solving for x, okay, or whatever letter we're looking at. Okay. But always remember, for stationary point, it's always when the first derivative is equal to 0. Okay, so you set the first derivative equal to 0 and then solve it, whether it's a quadratic, a cubic, a quartic, a quintic, okay, so on and so forth. Okay, solve it, using the formula, okay, or whatever it is that you're given. And hopefully you can recognize that when I do that, okay, this quadratic here has no real solutions, okay, because b squared minus 4ac is less than 0, okay, so a is equal to 1 equals 2, c is 3, so you have b squared, so you have 2 squared minus 4 times a times c, so times 1 times 3. Then when you work it out, you get 4 minus 12, which is less than 0. Okay, so we have minus 8 less than 0. Therefore, that quadratic has no real distinct solutions. Hence, why when you have one stationary point, that's when x is equal to 0. Okay, so that's when 10x squared is equal to 0. We solve that, we get x is equal to 0. Okay, it's like a repeated root. Okay, thanks for watching.